You've been lied to your entire life by your teachers, your maps, and probably your parents. Mount Everest is not the tallest mountain in the world. Now, before you angrily rush to the comment section to cite your third-grade geography textbook, we need to clarify some terminology. Mount Everest is the highest mountain in the world. But highest and tallest are two completely, entirely separate things, and confusing them is basically a geographic crime. Everest's peak sits at an undeniably impressive 8,848 meters above sea level. This is the gold standard we use for measuring basically everything on the surface of the Earth. We use sea level because it's a convenient, mostly uniform, wet blanket wrapped around our giant space rock. It gives us a consistent baseline. If you are standing at the beach, you are at 0. If you are in Denver, you are at 1,600 meters. Simple, right? Except, it's completely absurd when you think about it for more than 5 seconds, because the sea isn't level at all. It has tides, it has currents, and it sloshes around based on the gravitational pull of the moon. But scientists averaged it out over a bunch of years to create a mathematical model so we could all agree on exactly where 0 is. But here is the problem. If we are talking about how tall something is, we don't measure it from an arbitrary line of slashy water. We measure it from the absolute bottom to the absolute top. If you go to the doctor to get your height measured, you don't stand on a 3-foot stool, have the nurse measure from the floor to the top of your head, and then proudly declare to the world that you are 8 feet tall. That is exactly what Mount Everest is doing. Everest is sitting on a really, really massive chair called the Tibetan Plateau. Its base sits comfortably high up in the Himalayas, meaning the actual mountain part. The rocky bit jutting out from its immediate surrounding base is only about 4,600 meters tall. It's essentially a moderately large mountain standing on the shoulders of an incredibly high plateau wearing a trench coat. Which brings us to the actual tallest mountain. But right before I reveal the mountain that completely obliterates Everest's ego, I need to remind you to subscribe to this almost dead YouTube channel. Seriously, the algorithm has completely forgotten we exist, the views are surviving purely on life support, and you clicking that subscribe button is mathematically the only way we can afford to keep the electricity on in the recording booth. Do it for the algorithm. Okay, back to the giant rocks. The actual tallest mountain on Earth isn't even in the Himalayas, or the Andes, or the Alps. It is chilling in a tropical paradise. It's Mauna Kea, a dormant volcano located on the Big Island of Hawaii. If you apply the perfectly logical base-to-peak method to Mauna Kea, things get ridiculous very fast. Mauna Kea's peak is 4,205 meters above sea level, which is a respectable height, but practically a molehill compared to Everest. However, Mauna Kea's base isn't on land. It is hidden way down at the absolute bottom of the Pacific Ocean floor. From that underwater base to its snowy peak, Mauna Kea measures a staggering 10,210 meters. That is well over a kilometer taller than Mount Everest. It's a massive shield volcano that grew layer by layer over a million years. It's just that most of Mauna Kea is currently underwater, basically wearing the Pacific Ocean like a pair of overly high-waisted pants. So, if we pulled a supervillain move and completely drained the Earth's oceans, which would be terrible for global trade, the climate, and the whales, Mauna Kea would clearly be the undisputed, very visible champion of tall things, and Everest would look like its slightly underwhelming little sibling. But wait, there is yet another twist, because measuring from sea level is flawed, and measuring from the base is highly subjective. Who even decides where a mountain's base officially starts anyway? It's just rock blending into more rock. So, what if we use the most objective, scientifically foolproof starting point possible? What if we measure from the absolute center of the Earth? Because our planet is spinning at roughly 1,600 kilometers per hour at the equator, it experiences centrifugal force. It bulges outward in the middle, exactly like a pizza dough flattening out when you spin it in the air. The Earth is not a perfect sphere, it is an oblate spheroid. This means that sea level at the equator is actually over 21 kilometers farther away from the center of the Earth than sea level at the North or South Poles. Enter Mount Chimborazo, a very inactive stratovolcano located in Ecuador. It sits practically right on the Earth's equatorial bulge. Because of its prime real estate, Chimborazo gets a massive geometric head start. Even though its peak is only 6,268 meters above sea level, which wouldn't even crack the top 100 highest mountains in the Himalayas, if you measure from the dead center of the planet's core outwards, Chimborazo reaches a distance of 6,384 kilometers. Everest, being stuck way up at 28 degrees north latitude where the Earth is much narrower, completely loses this race. By this metric, Mount Everest is over 2 entire kilometers shorter than Chimborazo. This means that the peak of Mount Chimborazo is the single point on the surface of our planet that is the absolute closest to the Moon, the stars, and the endless void of space. If you want to get as far away from the Earth's core as humanly possible without getting in a rocket, you don't go to Nepal. You go to Ecuador. So, to recap our geographic existential crisis. Mount Everest is the highest mountain above sea level, making it the hardest to climb if you happen to enjoy things like breathable oxygen and not freezing to death. Mauna Kea is the tallest mountain from base to peak, making it the actual largest physical structure of a mountain on the planet. And Mount Chimborazo is the highest point from the center of the Earth, making it the literal closest you can get to space while keeping your boots firmly on the ground. Everest is basically taking all the international glory on a technicality. It's the guy who wins the 100-meter dash but only because he was allowed to start at the 80-meter line. It's a great mountain, but it desperately needs a reality check. Next time someone brags about wanting to climb Everest, just casually remind them they only want to climb a medium-sized rock sitting on a really high stool.